equals c squared, but they may not give it to you with a and b. You have to know that these are the legs.
Yep, and c is the hypotenuse.
Right. And then they could even be more unclear like I've given you here and just give you other letters.
Yep.
Are they giving you the two legs or the leg?
The two legs.
Yeah.
Should be 12 squared plus 10 squared equals c squared. So then it'd be 144 plus 100 equals c squared. So 244 equals c squared.
Good.
And the square root of 244 is...
So this does not work out nicely. And that's, I guess, where we're going to start is, do you know how to reduce a root that does not work out nicely?
Yeah. So then divide by 4, I think, first, because 4 is...
So you actually start with 2 because 2 is the smallest prime number.
Okay, but if you factor out 4, I thought you could like bring it outside of the...
So you can. You want to do this iteratively, though, and you really want to find a way to do this that it always works. And dividing by 4 is more difficult than dividing by 2 because you're going to see you just divide by 2 twice.
Okay.
Okay, so do you see how you get down to 2 twice on this one?
Yep, so you'd have 2 on the outside times the square root of 61.
Yes.
Okay, so that would be the answer.
Yeah, now just to make that point here, let's really quickly talk about reducing roots because just to make sure that that has been made very clear here. So I always start with this one, the square root of 12. And you always start with the first prime number, which is 2, and then 3, 5, 7. You probably will never get much past that. Okay. But you always start with 2. 2 times 6, 2 times 3, and you look for pairs.
Yep.
You bring the pairs out. So this becomes 2 square root of 3. All right.
Okay.
Now, it doesn't always work out that it's 2. Like if I give you the square root of 18, this is 2 and 9. And now you got to try a different prime number, 3. 3 and 3. But see how you still get a pair to come out?
Yep. This
would be 3 square root 2. So you have to be on the lookout for those. All right. So why don't you try the square root of 40 for us, please? And I recommend trying this method I'm showing you here.
Okay. So then 40 comes 2 times square root 2 times square root of 10.
Yes, very good. Now it's also possible that you can get more than one pair. Okay, so let's look at the square root of 72. 2 and 36, 2 and 18, 2 and 9, 3 and 3.
And you bring the 3 and the 3 out, and then the 2 and the 2 out, and then it would be 2 times 3 times the square root of 9.
What's left over?
2 times 9.
The 2. The 2 is left over.
Oh yeah. So then
it's
times 2.
It's the number on the outsides. If you're doing a factor tree, sometimes you do a factor ladder. If that's the case, this becomes 6
times square root of 2.
Yeah. Okay. Now, if that made sense, what is the square root of 32? Try that one for.
Four square root of 2.
You got it. Good. Okay. So that's related, and I mean we could spend a ton of time on that, but really you've got to be able to do the Pythagorean theorem stuff. So let's look at a few more of these. All right. So again here, a squared plus b squared equals c squared.
Yep.
You got to decide if they're giving you the two legs or the leg and the hypotenuse.
8 squared plus 16 squared equals L squared. And 64 plus 16 squared.
Are you allowed to use a calculator?
Yes.
Okay, yep, please do, because especially for the larger ones, until you get used to them, because 16 squared is 256.
Yeah. So then that's a not nice number, so I'm gonna have to factor it out. So then it becomes 2 and 160, which becomes 2 and 80, 240, 2 and 20, 2 and 10, 2 and 5. And that'd be 2 times 2, 8 times, so it's 8 times the square root of 5.
Now here's how I check that. I square 8 and I multiply it by 5, and is 64 times 5 equal to 320? Yes,
Yes.
that's how you check. Good.
Okay.
Okay, so the next type of Pythagorean theorem problem that you might get is where they give you a hypotenuse and a leg.
It's pretty much the same thing, except you're just plugging in different numbers.
Yes, so I'll give you a couple of those to work on here.
Okay.
There is more to this. Like, I don't want you to think like you've got it. From what you told me, this is very surface level in terms of
Yeah.
like what you're doing. But um, yeah, go ahead and give this a try. Solving for F,
So
please.
16 squared equals 36 plus b squared, and 16 squared is 256. 256 minus 36 is 220 equals c squared square root 20. So then it's a not nice number. So then 2 squared is 55. Then you get 5 and 11. So no, so it'd be 2 times the square root of 55.
So you got 6 squared. Are you using the letters F, G, and H, or are you
I usually use A, B, and
A, B,
C.
and C? Okay, that's fine. Equals 16 squared. So you got B squared equals what did you get over here on the right?
36 plus
Two,
B squared,
but you got
or
220.
220, yeah.
Yeah, that's what I was asking. And what is your answer again? You said 5.
2 times the square root of 55.
Okay. Yeah. That is correct. Okay. So the only way to maybe make these more difficult, I guess, or awkward is to um manipulate some of the numbers. Like, let's say this is um C, and this is the square root of 14,
Yep.
and this is 7, for
Yep.
example.
So then you just square all of it, since you
Yeah.
have to have C squared anyways. It'd be 14 plus 49 equals C squared.
Be careful here. So I've done this intentionally by using the wrong letter, or using a letter in the wrong place.
Oh, yeah, I see
What
that.
are
Okay.
you have to look at this as leg.
Yeah. That'd be 49 equals 14 plus C squared, or
Okay.
plus B squared.
Okay.
So then minus 14 square root of, is that 35? I don't think 35. But I think 35 is a prime. So
It,
I think it's just the square root of 35.
it's not prime, but it's only two factors are two primes.
Yeah.
There's no
Yeah.
now, do you think you'll get any word problems?
Oh, yeah, but that just requires like drawing it. So like a ladder's leaning against a house.
Yeah.
Yeah.
Let's do at least one or two of these, because it's these are, you just mentioned it. The ladder is kind of the classic
Yeah.
problem here. So what I'd like you to do is first draw a picture, and then um, I will draw it and see if we're in agreement
Yeah.
before.
We don't know the hypotenuse. So then the ladder is 10 feet long. So that's the height. And then the base is, so it would be,
Okay, so I heard some things there. We do know the height of the ladder. The
yep.
ladder is right here though on the it is the hypotenuse.
The ladder is 10 feet long.
Yes. It's leaning up. It's like the ladder's not going straight up and down on the wall. It's leaning up at an angle.
I thought it meant it was 10 feet like tall, not
Yeah.
10 feet for the hypotenuse.
No, so that's why we're doing this. Yeah, the ladder's always got a little angle to make with the wall.
Well, I knew that, but I just thought it meant by 10 feet long that would be like the height of it.
So the ladder's the same height. The ladder's the same length, whether it's along the ground or like this or like this. It's always 10. Like there's
10.
physically a ladder here.
Oh, because that last piece is the wall. That's not the ladder.
Yes, yes.
Okay.
And that's why we're doing these, because it's like, oh yeah, I gotta remember,
Yeah. So then 100 equals
now where does the 3 go in this
9.
drawing?
The bottom 3 feet
Yes.
away.
So you can change this to y.
Okay. So then I got c squared equals 91. But then I think the two factor. I think it's 91. I think 91 might be prime too.
Yeah, I think it is. I think it is prime, or you
Yeah.
got your height is square root of 91. Now you do have to give units here, so it's in
So
feet.
91 feet. Yeah.
Yeah. All right, good. So here is, and you said you're allowed to use a calculator. Is that right?
Yes.
Okay. So this one, the numbers get a little large here, but this one's more going to be more intuitive to you because you know this situation.
Okay. So then we don't know the hypotenuse. So then it's 100 by 130. So then 100 squared is 10,000 plus 130 squared. 16,900. So then that's second square root of 26,900. This isn't gonna be fun.
You said you're allowed to use a calculator, right?
Yeah, but it doesn't come out evenly.
Well, yeah, right. But you get these numbers. So what is it the square root of?
Oh, wait. So then 100 has a square root. So then it'd be 10 times the square root of 130.
No, you can't do that. But what is 100 squared plus 130 squared?
26,900.
Okay. So you kind of mentioned this to me earlier, and you can do this.
Divide by 4.
It's 269 times 100. And
then and then that's 10 times 269.
Yes.
Okay, and then
so, this is why we're doing this, because these are just things that you may or may not know until do this. So okay, here's another one. Then we'll move to volumes after this.
So then the hypotenuse is unknown.
That's right. But the drawing is important here. And there's a few different ways to do this, but I usually draw a little crosshair, and I'll let you attempt to draw this before I show you.
Okay, and then he walks 125 meters north. And that's the up. And then 200 meters west.
See, the order doesn't matter here, but it might matter in another problem.
Yeah, so it's like yeah, that's what I got.
Okay, so again, to find the diagonal, you got to square 200 squared plus 125 squared.
55625.
do you have a number for this one?
Yeah. Square root of 55,625.
Like this?
Yep.
All right. Now, see, this one doesn't work out as nicely. What you
We might
could
be able
do,
to divide by 25.
yeah, so this is where the algorithmic approach is a little better. Like, so does it, you got 2 does not work, but does 3. Yeah. And 3 is do the digits add up to a multiple of 3, 10, 6, 8, 23 does not work, but 5 does. Or like
Okay.
what you're trying to do there, you're trying to find powers of 25. So again, since you have a calculator, you could do 5 and
Yeah, I'm just trying to do so because 25 has a square root, so I can immediately take 5 out of the equation. So like divide by 25 and then immediately take 5 out of the equation.
yeah, and that's fine. You just you have to find a way that will always work. Um,
And then
I think we're running out of,
I got 25 times the square root of 89
yes. And then we just need some units here.
meters.
Meters, good. Okay. Um, that's great. We could do a lot more problems than that. The for volumes,
It's just cones, spheres, and cylinders.
okay. So we'll start with cylinders.
V
Uh,
equals pi r squared h.
yeah. So pi r squared h. Uh, there's only really 2 types of problems they can give you. One is they give you
They'll give
R and
you,
H to
yep,
find V, or
or
they
they'll
give you,
give you v in another variable, and then
right, right, okay. For cones,
1/3 pi r squared h.
so notice they're exactly the same except for that.
Yep,
And then for spheres, do you have,
4/3 pi r cubed.
okay. All right, so I guess I better find a few problems here to test you on. I mean, these aren't,
It's just plugging in numbers, really.
yeah, it is. Is there a reason you're doing sort of like this geometry unit?
So I think they're because this is like the pre-algebra geometry, and then I'm going into geometry next year. So
Okay,
I think that's why.
all right. No prisms, just what you said here.
Yes, that's all we
Okay,
learned.
all right. So I'm just looking for some problems because I mean these aren't going to be very interesting if I just draw the shape and do this. So um, this was close. I'm just looking for some problems that are more interesting. All right, I guess I can't find any. So I'll just try to make this up. Okay, so let's say it's a cylinder. I tell you that the diameter is 18 inches and the height is 18 inches also. So it's a square cylinder. What's the volume?
So then it's a cylinder, so pi. Where's my pi button? Second pi times 9 squared. Pi times 81 times 18. 4,580.44.
So your answer should be exact, meaning like leave the pi in.
Oh, okay.
So
Well,
so you're
so then it would be 81 times 18.
yes. And so then we need units as well.
Yeah, so 1458 pi inches cubed.
Cubed. Good. Okay, so I found a harder problem here that is related to the triangle stuff. Okay, so here it is. There's definitely a gap here in finding difficult problems. So it wants you to find the volume of the cylinder, and the 17 is representing the diagonal distance.
Okay.
Okay, so you just did this, but the volume requires the height. How are you going to find the height
So
of?
it's a triangle, so I'd have to find the
Yes.
yeah. So then so then it gives me 17 squared equals 7 or no, so 17 squared equals 15 squared plus b squared. So then 17 squared is 289 equals 225. 289, 64, and then b equals 8. Then the radius is 7.5 squared times 8, 450 pi. And then there's no units.
Did you say that h is 8?
Yeah,
Okay, yeah, that is correct. And then what did you use for the radius?
8 or 7.5. Sorry.
Okay, so you have 15 over 2, and then the height is 8. So you get 225 over 4 times 8, which is 450 pi. And like you just said. All right,
Yep.
so here's another problem for you to look at. This one is a calculator problem, meaning like it says in the problem to round to the nearest tenth.
Okay.
So go ahead and try that,
So
please.
the radius equals 7 inches. And then so 7 cubed is times 4 by 3. So then 457.3 pi inches cubed.
So this time it says to the nearest tenth. That means
Yeah.
that means you're using pi. You're putting pi in your calculator.
Oh, yep.
Yeah, that's the difference here.
So then 1,436.8 inches cubed.
Yes, perfect. Okay, so here's a new problem for you to think about is, let's say I give you a triangle, okay, like this, and this is not drawn to scale, but this is 5 and this is 13, okay, and it's spun around this axis, okay. What shape would this create?
A cone?
Yes. Okay. So now if I wanted you to find the volume of this cone, how would you do that?
1/3 pi r squared.
H.
Yeah.
Do you have the radius?
So since it's being spun around, the radius is 5 because that's 1/2 of
Okay.
the diameter.
What about the height?
I'd have to do the 13 squared equals 25 plus c squared.
Yes. So go ahead and find the height and calculate the volume, please, exactly. And let's call these, let's go meters on this one.
Okay. Then the height is 12, so then v equals 1/3 pi five squared times 12. So v equals 1/3 1/3 of 300 pi, so that equals 100 pi, and 100 times pi is 300. So I got 314 point. You want to the nearest 10th?
Exact this time. I want the exact answer.
Oh, okay. So then v equals 100 pi.
What is the height?
The height was 12 meters.
Good, good. Okay, yeah, so it's 100 pi meters cubed. Good. All right. So this one's a little bit awkward. Let me just, maybe drawing the picture is the hardest hardest part of this. A right circular cylinder. They're all, for now, they're all right cylinders.
Yep.
They do have ones that are bent.
Okay.
But we're not worried about that. Although we probably should do one like that. So I'll do that next. This right circular cylinder is circumscribed about a sphere. Okay, so what they're saying is that there's a sphere inside the cone.
Oh, so then I have to figure out the volume of the sphere?
Cylinder.
Oh, okay.
But you might as well find the volume of the sphere first. That'll be part A. We'll do that.
So then the volume of the sphere, so then 3 times 3 times 3 is 27. Times 4 divided by 3 is, so then 36 pi is the area of the sphere.
Volume of the sphere. 4/3 pi r cubed, right?
Yep.
3 cubed. Yeah, so that's 36
pi
inches cubed.
Yep.
Now, what you have to think about is, like, how does that translate to the relevant dimensions in the cylinder? Like, what do you need to find the volume of the cylinder?
So the radius is 3, so we know what the radius is.
Okay, I agree.
So it's v equals, I would find the volume. So does the sphere take up all the volume in the cylinder?
The idea is that it touches on the top and the bottom. That way you know the height of the cylinder.
But it doesn't take up all the volume.
I'm trying to say this politely. You're asking the wrong question. You want to find the height of the cylinder. The height is the same height as the height of the sphere. It's 2 radii, one up and one down.
Is that, oh, because the sphere is symmetrical.
So it's like the answer is no. Like, have you ever bought tennis balls?
Yeah.
So they don't fill up the
whole can.
Yeah.
Okay.
There's air in between.
So, but the height is equal to 2 times the radius?
Yes, exactly. And that's what I was trying to get you to,
okay.
to visualize.
So then the height is 6. So then, so second pi. So then pi times 6 squared, or pi times the radius was 3 squared times 6. But you want that in terms of pi or exact?
Yeah, pi. Yeah, exact.
54 pi.
Units.
Inches cubed.
You will get marked off if you don't drop the units in there.
Yep.
Okay, new problem. Go ahead and read it. Let me know if you have any questions. Whenever you see something like rounding or the approximate value for pi, that means that you are going to use the calculator and give me an approximation, not an exact answer.
V equals 1/2 pi r squared h. And V equals 1/2 pi 20 squared times the length is 56 feet. Oh, but the height is 2 times the radius. So then the height is 40.
You don't need the height in this problem. So this one's on its side. This is the height.
Oh, okay. Then times 56. Okay, so then 20 squared. So 400. And 400 times 56. It's 2240. Then I got the volume equals 35,185 point. Oh no.
So
then
it's
V equals
just
3,500,186
okay.
feet cubed.
This is what I got, and I heard all the right numbers.
Yep, that's what I thought.
If it says to use 3.14, you have to use 3.4. If it doesn't say anything, then you use pi. You got to be really careful here because I assume your teacher's gonna be a little bit more deceptive than just to give you, picture with all the right dimensions. But
Yeah.
okay. Here's a working backwards question. So we'll do this one.
So the volume is 47.1. 1 equals 1/3 pi times 3 squared times h. So then what's the height? So then 47.1 times 3. 141.3 equals 9 pi times h divided by parentheses 9 times pi is to the nearest inch, then 5 inches.
Yes, the height is 5 inches. Good. Very good. Okay, now this is maybe the most complicated problem you would see. It's a composite figure. It's a cone and a
sphere. So then it'd be 1/2 of the cone. Or sorry, it'd be 1/2 of the sphere. So then V equals 1/2 of 4/3 is 2/3, right? Yeah, so V equals 2/3. Can I just do that instead of having it be times 4/3?
Yeah, you could do 2/3 pi r cubed.
Yeah, that's what I was gonna do. So 2/3 times pi times 6.
So what is the height of the cone?
It's 2 times, so 12.
Nope. You gotta
wait, I have to do the triangle thing.
Yes.
I'm still trying to figure out that sphere really fast.
Okay.
216 Do you want it in terms of pi? Or...
Yeah, give me exact this time, please.
Okay, so then 216 divided by 3. 72 pi. So then the triangle, so then 6 squared, so then 36, 100 equals 36 plus c squared. So then 64, yep. Okay, so then c equals, so the height, 8.
8,
So
good.
v equals 1/3 pi times 64. Wait, no, r, so then times, so then 1/3, 36 pi times 84, or times 64.
Yeah, you got too many multiplications there. Your radius is 6 squared.
Yep. So then I got
And
v equals 1/3
your
30
height,
of 36 pi times 64.
8's not squared though. 8 is just the height.
Oh, oops. 8. So then 288 pi divided by 3 is 96. 96 pi, and 72 plus 96. 168 pi.
Yeah, we got a mistake here. Good. No units, so you don't have to.
Yep.
All right. So the last type of problem is where instead of it being a composite, you cut out. So you'll see what I mean by this one. The cone is cut out of the.
So then I would figure out the volume of cylinder and then find the volume of the cone and then subtract.
Yeah. Now I'm going to make this one nicer. So I'm going to make that. Oh, they're giving you the height. That actually is fine. Okay. Yeah, we can use that. Yep. So you got to take the cylinder and subtract the cone.
So V for the cylinder equals, do you want it in exact terms?
Yes, exact. Yeah.
And, the radius is 25 times 6, 150 pi for the cylinder. And then for the cone, it's 1/3 of 150 pi. So then times 2 is divided by 3 is 100. So 50 pi.
And you're subtracting, so it's.
Oh, yeah, 100 pi.
Yeah, and that should make sense because there should be 2/3 left over inside a cone. So whenever they give you a cone thing to drink out of, they're not giving you very much. Now, real quick, we didn't cover this, but I guess it could be on your test, is they could give you something really weird like this, and they could tell you that, oh, I don't know, they could tell you that this is 17 and this is 8.
Then I have to do the triangle thing to find the height.
Right, and the height's over here. So that's the only other thing that you might be asked.
Then how would I find the radius?
It would be given.
Oh, okay.
Okay, so the radius is, yeah, whatever, it'd be 4, for example. We don't have to do this, but that's the, yeah, that's the only other problem you might see. All right, well, that is it for us for tonight, Braeden. So